Hello. Vishnu, we are going to discuss the portion, and its name is biochemistry. Okay. So, bio means life and chemistry. So, actually, all those living organisms which are present in my body, like the carbohydrate, proteins, fat, okay, all these things are present in my body, right? Vitamins. So we are going to discuss the structure of all these compound and the nature of these compound. So what do you mean by the biochemistry, or we can say biomolecules? So we can say the cells that are made up of thousands of chemicals or thousands of molecule, okay, and these molecule make up our cell. These molecules help in the formation of our cell. So these are called the biomolecules. Okay. So first of all, we can say it here. So these are made up of cells are made up of thousands of different chemicals in the molecules in our body, of course, chemicals or the molecules, and these molecules that make up the cell that make up these cells. So these are called the biomolecules. Okay. So example we can take, Vishnu. What are the example for the same? So example we can take proteins, carbohydrate, lipids, carbohydrate, and the nucleic acid.
So essentially, macronutrients and nucleic acid.
Yes, macro you can say because they are quite complicated and they have larger structure. Okay, micro means very small. Like if I say protein is made up of the amino acids. So amino acids you can say micro, and protein which is made up of so many amino acids. So we will call it as macro. Okay, so these are the complicated structures. Okay, so after that here. Uh, there is a there's some total of different types of the molecule that make up our body or that make up our cell. It is called cellular pool. This sum total of, okay, and that cellular
The
pool is
what?
cellular pool.
Pool.
Yes, I am writing here. So we have the second one is known as the cellular pool. So this cellular pool is actually what? So it is the all the different types of molecule which are present in our cell, or you can say that make up our cell. So it is called cellular pool, and can be divided into two part. So inside our cell, or our cell is basically divided into two part: aqueous. Aqua means which can be dissolved into the water.
Also, water soluble and fat soluble, right?
Yes, water soluble. And second one is the non soluble, not only about the fat but about the everything. Okay, every content inside the cell. So first is in the aqueous phase, and other one is the non-aqueous phase. Okay, we will discuss it later, of course, because there are so many things. So what do you mean by the cellular pool, Vishnu?
Um. Uh. So
All
like there.
the content which are helping in making our cell. Suppose if I have taken my one cell, suppose, okay, and whatever I see in that cell, like that how much amount of protein, how much amount of carbohydrate, how much amount of amino acid, so everything is the cellular pool. Okay,
So all the contents, chemicals, and stuff that makes up the cells.
exactly, very
Okay.
good. Yes, and it can be of two type: aqueous and non-aqueous. Okay, now if I talk about the structure of the water, okay, because you have to study about that as per your syllabus. So if I talk about the water, so water means you know it very well. We have the oxygen and this is the hydrogen. Okay, so you know it very well. Oxygen is quite electronegative. So oxygen is quite electronegative and it is making bond with the hydrogen. So it has the tendency to attract the electron pair this. So it will become the delta negative, slightly negative. Why? Because it is taking up the electron. And this hydrogen is becoming delta positive, electropositive, because it is giving its bond towards the oxygen. So there is a electronegative difference, yes or no? Okay, so that's why water molecule is polar or the non-polar. It is polar, right? Because
Polar.
polar means whenever there is a separation of positive and the negative charge, it is called as polar. So water is the fundamental unit of all the living organism, right? Of course, we know it. Without water, nobody can survive. So it is composed of the two hydrogen and the one oxygen.
Could you
And
explain the definition of polar again?
yes, whenever we see, I mean, polar means what? Whenever you have the molecule and you see positive and the negative charge, okay? So this is called polarity, or you can say polar molecule, okay? See, if I say oxygen molecule, so oxygen molecule, so in this oxygen is like this. Can you see any positive or negative charge here?
No.
No, because both molecules are same. So no positive, no negative. So it is a non-polar. Non-polar means where we can't see any positive and negative charge. But in the polar, we can see negative and positive charge because of the electronegativity. Oxygen is quite electronegative than the hydrogen. That's why it can attract share pair electron towards its side. That's why it become the polar. Okay. Okay, so water is a polar molecule, and of course, it also involved in the hydrogen bonding. So for the hydrogen bonding, we need hydrogen and we need one electronegative element. Remember, so hydrogen bonding, we need two things, hydrogen and the electronegative element. Then of course, hydrogen bonding can take place. So if the hydrogen bonding take place within the molecule, then it is called intramolecular. But when the hydrogen bonding is taking place with the other molecule, it is called intermolecular. Okay, so just say I can say that whenever there is a competition between the two different school, you will call it as inter-school competition. And when the competition inside your own school, I mean in your school there are two classes, competition between two, it is called intra-school competition.
So it's in between. Oh yeah, so it's in between inter and intra, right?
Yes, inter and intra. Okay, so I'm just going to show you. Don't worry. Suppose if I have a structure something like this. Suppose if there is a one NO2 and one OH. So if there is a like bonding with that, oxygen is this and hydrogen is this, one electronegative and one hydrogen is this. So it is taking place within the molecule, na? This bonding. So that's why we will call it as intra because it is within the molecules, it is same complete one. But if I say there are two different molecules, like suppose if it is a NO2, okay, and if there is another one, there is a OH, like that. So if the bond is between the two different molecules, then it is called intermolecular, because there are two different molecules now. So that's why we can say if it forms the hydrogen bond within or with other molecules. So I mean here this water can do anything. Because can you just see that hydrogen is also there and oxygen is also electronegative. So H2O can do both the things, intermolecular and intramolecular. Okay, so both the property it has. So we just write it down. Water is a polar molecule and it forms. You can just note it down. Yes, water molecule is a polar molecule. Water molecule is a polar molecule and it can form or you can say it forms hydrogen bonding within, it means intra, or with other polar molecule, with other polar molecules. Okay, so there is a phenomena, and that phenomena is known as what? Like dissolves like. So same thing can dissolve only same thing. What does it mean? Its simple meaning is water is a polar. Okay, so if you add in the compound which is also a polar, so of course it can easily dissolve in that. Okay, so it will dissolve in that, and suppose if you have a oil. Okay, so if you have a oil, what do you think? Can it dissolve in that?
It won't because it's not a polar element
Yes.
or
So,
substance. Sorry, yeah.
if I to, because water is what? What is a kind of lipid, kind of fat. Okay, so it is not going to be
Oil or
dissolved.
water? Isn't oil the
Oh,
lipid?
I'm saying lipid, fat. These are kind of oil, na?
Yeah, yeah, yeah. Okay, okay. Yeah.
Oil. So it means it is not going to be dissolved in the water because it has some different property. The oil is non-polar, water is polar. So that's why unlike things cannot be dissolved in the like things. That's why. Okay. So of course, I guess you have also heard about that when the same molecule attract the same molecules, it is called cohesion. But when the water is attracting the different molecule, it is called adhesion. Okay, like if you have a glass of water, so the glass of water, so glass and the water, they are sticking together. So when they are sticking together, so of course it is what? It is adhesion. And water is water also attracting with each other, so we will call it as
Cohesion.
cohesion. Yes.
So
So
wait. So how do you spell adhesion?
yeah, yeah, yeah,
ADH.
I'm writing. Just hold on, sir. Just 1 second, just 1 second. Yes. So just so about the water, you should watch this. Just give me 1 second.
Life, as we know it, would not exist without water. Over 70% of the planet is covered in water, and our bodies are around 70% water. But why is water so important? The structure of a water molecule and the fact that it is capable of forming hydrogen bonds with multiple other water molecules simultaneously provides water molecules with some very unique characteristics. These include the ability to act as a universal solvent, the properties of cohesion and adhesion, a high surface tension.
Yes. Now, can you see that cohesion means attraction between the same molecules, and adhesion means attraction between the two different molecules. S- And surface tension means they have the tendency to reduce their surface, right? Cohesion, it is the most important property of the cohesion, right? And yes, okay, so these are the main two properties. And of course,
A
hydrogen
high
bonding
heat
also.
capacity. And
High heat capacity means what? It require a high heat to break their bond. Like when you are going to heat up the water. So when you are going to heat up the water, so it can quickly evaporate or it can quickly convert into vapor. No, so we need at least 5 minutes, at least when you are going to use a gas stove. Okay, and of course in the geyser at least it require 2 to 3 minutes at least. Okay, so that's why it require a high heat to if you want to convert into vapor. So why? So because when it converted into vapor, so of course bond is going to be broken. So we need to break the bonds. Okay. So when we are giving the high heat, so that is called the heat capacity. Amount of heat required to convert a liquid into gaseous phase. So this is called heat capacity. You will study in the different topic which is called the thermodynamics. It is a branch of chemistry. Okay. And of course, density can also get changed. In the solid, there is a less density. In the water, it has a little high density. Water. Okay. So different states and different density. And when it convert into gases, then it becomes very less density.
Changes in density based on temperature. Let's take a look at each of these in turn. Water is often called the universal solvent, which means that many substances dissolve in it. Water's solvency has to do with the polarity and hydrogen bonding ability of water molecules. When a salt, such as sodium chloride, is placed in water, the negative ends of the water molecules are attracted to the positively charged.
Yes. Can you just see that? If you like, these are the water molecule, okay, minus and plus plus. This is water, this is water, this is water. But when you added a NaCl in it, so Na is coming between them, and this negative and positive, they are attracting each other. Negative of oxygen, negative of oxygen of other molecule, and now Na is coming in between them. Okay, that's why salt can easily dissolve in that, because there is an
Sodium
intermolecular
ions,
space.
and the positive ends of the water molecules are attracted to the negatively charged chloride ion.
Okay, and chlorine is coming between the positive. So positive sodium is coming between negative, and chlorine is coming between positive. So with that, all the Na plus and Cl minus are accommodating inside the water, right? So this is how it is going
This
to be
attraction
dissolved.
causes the sodium and chloride ion
And that's why we call it as universal solvent. Most of the thing can easily dissolve in it because of this phenomena, because it has positive charge as well as negative charge. So most of the polar compounds can be dissolved in it very easily.
to break up or dissociate in water. Why is this important? Since our cells are mostly water, these solutions of ions and molecules allow chemical reactions to occur much more frequently,
Of
which
course, you know it, our body mostly contain water. And whenever we are eating something, anything, so of course, because of these ion, so
is an important feature to allow organisms to respond to their environment. Water molecules are also cohesive and adhesive.
as I told, cohesive means, Vishnu, yes, cohesive means what?
Cohesion means bonding with the same type of molecule.
Yes, by which color it is showing, by which color it is showing cohesion?
I'm assuming yellow.
Yes, exactly. This is one water, this is other water, and this is other water. So it is, there is a attraction with same molecule. It is called yellow, right? Yellow bonding. Okay, and this is RBC, and it is trying to attach with our artery or vein. Can you just see that blood vessel? Little bit attraction. So this is called the adhesion. Okay.
The hydrogen bonds in water cause water molecules to stick together, a property known as cohesion. Polar bonds also give molecules an adhesive property, or the ability to cling to other polar surfaces. Why is this important? Well, water fills the internal transport systems of plants and animals.
Yes, you know it, in the plants, without this property, a transpiration can't happen, right? There is a loss of water from the surface of the plant so that it can take up the water from the soil to the all parts of the plant, right? Because of this cohesion and the adhesion. So cohesion means water, one water is attracting other water, and saying, "Yeah, yes, come up, come up." Okay, and that water is also attached with the stem. Okay, with the help of the addition, it is going upward movement. Okay, so whenever there is a loss of water from the surface of the leaf, then it is creating a pull, a suction pull, and water is coming from down to up. Okay, and reaching to all parts of body. So this is how they meet with your, with the water requirement.
Because of these cohesive and adhesive properties, surface tension.
Mm,
Because
yes, see the surface
water
tension.
also has a high level of surface tension. Because water molecules at the surface are more strongly attracted to each other than
Can you
to
just see that? So, downside water molecule are randomly attached, but the surface water, they make a film, right? They make a layer. Okay, it is a kind of film, so that's why it creating a tension. Like most of the particles are attacking on the surface, okay, and it is trying to make a film. So this is known as a surface tension. Okay, they are all together. So
The air above, water molecules cling tightly to each other. The surface tension of water explains why it beads up on waxy surfaces and why water striding insects are able to walk on the surface of
yes,
water.
have you ever seen that? Like whenever
Yeah,
insect is coming on the water, so it is not sinking. That
it's
molecule,
floating
that
on the
yes,
surface tension.
yes, and they can even walk on that.
Yeah,
Okay,
I've seen
why?
them.
Yes, because it's a complete film. Film means a very thin layer, like a plastic bag, plastic layer, something, something. Okay.
Water. Water has a high capacity for
As I
heat.
told you, heat capacity means amount is like amount of heat required to convert into vapor gas, right? So it require a high heat. So all these are the properties which you have already studied. Okay. So it is all about your water. Got it? So now we are moving towards the, of course, carbohydrate, protein, fat. But before I proceed with the protein, carbohydrate, and the fat, I want to tell you one thing: carbon compounds. So if I talk about the have you ever studied about the carbon compound like alkane, alkene, alkyne? No. Okay. Okay, got it. Okay, okay, type. Okay, so if I talk about the carbon compound, so carbon has the valency of 4, remember. Okay, okay, because carbon atomic number is 6. So 2 and 4 we can say. So 4 means it can lose the electron or it can gain the electron or it can do the both. So carbon has a 4 valency, so it means it has more chances to donate or to gain, and both are 4, right? Yes. So if it want to lose the 4 electron, then it becomes the 2, which is also the noble gas configuration like helium. And if it want to gain the 4 electron, then it becomes the again noble gas configuration, right? Hydrogen, helium, lithium, beryllium, boron,
Neon.
carbon, nitrogen, gas, neon.
Neon.
Okay, so 10 it would be. So that's why it becomes the 4 valency it has. So this is known as the tetravalency. So because of this tetravalency, it can do the both. And the last, it has the property of catenation. Catenation means carbon can form longer bonds. So one carbon can combine with the other molecule, other carbon, and it can make long bonds. I mean, you can say longer chain. Okay, so it has a unique ability, and that unique ability allows carbon to make bond with so many carbon and can make longer chains. So one carbon can attach with the other carbon, that carbon can attach to the other carbon, and it can form long, long, long chains. And it's a unique ability. Okay. So here we can say that, oh, you were saying something. Yes, kind of. Yes, we can say that it's a kind of polymer. Yes, kind of polymer we can say. So see one thing. Right now we are learning how to make compound and their name. So before I proceed with that, so you should know if there is a one carbon, so you will call it as meth. If there is a two carbon, you will call it as eth. If there is a three carbon, you will call it as prop. If there are four carbon, you will call it as but. You have to remember that. Learn it quick. Okay. If there is a five carbon, then you will call it as pent. Six carbon, you will call it as hex. If seven carbon, you will call it as hept. Eight carbon, you will call it as oct. Nine carbon, you will call it as non. It is not like October, November, December. Okay. 10 carbon deck. Okay. It seems like, but it is not. So octanon deck. So one carbon meth, two carbon eth, three carbon prop, four carbon bute, five carbon pent, six carbon hex. Okay, so these are what, these are the prefix, like we will use it in the compounds. Okay, so we will study these things when we make compounds. So now Vishnu, we have, suppose we have the, I'm going to tell you three main category. First is alkane, second is alkene, and third is the alkyne. We will study one by one. See alkane, see just this thing, suffix ane, and this is prefix meth. So it will become what? Methane. Methane gas, meth or ane, methane. So actually, alkene means what? Alkene means only single bond you have to use.
Oh, it's
In
single
the
bond, double bond,
yes,
triple bond.
in
Okay.
the alkene, at least not everywhere. One double bond should also be there. And in the alkyne, carbon triple bond should also be there. So alkyne means triple bond, alkene means double bond, alkene means single bond. Okay, and it is all about the hydrocarbon. Hydrocarbon means, okay, I'm going to tell, you
Oh,
know
is
it
it the
very well. Carbon has a,
hydrogen?
yes, four electron, and hydrogen has only one electron. So can they make the covalent bond? Covalent bond means they are using with each other. So hydrogen can take up the electron of carbon. Now hydrogen is happy. Now carbon is asking, okay, you are happy now, but what you have it done for me? So he's saying nothing. So he's saying then bring three more brothers. Okay, then yes. So three more hydrogen is coming. Okay, they are stable. I mean, they are also taking the electron of carbon. And now carbon is also taking up the electron of hydrogen, taking, better to say sharing, not taking. Okay, so they are using each other. Okay, for making, for getting the stability. So this is how. Okay, do you have any brother or sister? Okay, so if okay, brother or sister.
Sister?
Okay, okay. Younger or elder?
Older.
Okay. So suppose if there is a contract, suppose you are doing something for your sister. Suppose you are doing a homework for your sister, okay? And your sister is giving some chocolates to you, some kind of like money is giving like your sister is giving. So it's a kind of mutual benefit. A mutual benefit means, why? Because you are doing homework, or you are
Yeah.
doing something for your sister, and your sister is giving chocolates for that.
It's kind of like a symbiotic relationship.
Okay.
Mutualism. Yeah.
Yes, mutualism. Yes, symbiotic relationship, both are getting benefit, so same thing. So both are getting the benefit. Okay, so is that clear? Okay, so now you have to remember that, and now we are going to make the bond. If I say meth and ane, so it become the methane. So it means only one carbon. So if only one carbon, so of course carbon attached with the four. So hydrogen will come, and there is a mutual relationship. So what is the formula for methane? CH4.
Or
CH4. Okay. So carbon one. Is it like same if we say ethane? It means how many carbon, Vishnu? Two. So one, you have to write two carbon. One carbon can attach with the other carbon, single bond. So if one single bond is already there, so of course three are left for the hydrogen. So we can say what would be the formula? Very good. So we can say C2H6. Okay. So now you have to tell me the formula for the propane. You take your time. You can draw this structure.
sir, I got C C3 H8.
Yes, very good, very well. So C3H8, it means we have to draw the three carbons and they are well connected with each other. So three hydrogen here, two hydrogen at the middle, and three hydrogen at this side. So we can say C3H8. Okay, this is methane. Okay, as I told here. Now, can you tell me also about the butane? What would be the structure of butane? Yes, Vishnu.
C4H10.
C4H10. Okay, so carbon, 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 they are attaching with each other, and hydrogen 2, 2, 2, 2, and 3. So it becomes this C4 1, 2, 3, 4, 5, 6, 7, 8,
There's a
9, 10.
pattern.
Yes,
There's a pattern.
yep.
Okay.
And
Okay.
there is a relation also. Can you just see that? Carbon is increasing one by one, and hydrogen is increasing 2, 2. Like 4, 6, 8, 10. So there is a relation. And we can also make a then like formula. Alkene have a formula Cn and it become H2n plus 2. Am I right? 4 to ja. No, 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 no. One second, one second. If it was 4 and it was 6 and it is 8. So Cn H2n. What should I do?
It's not consistently linear. It's like an exponential thing. You can't just I don't think you can just do C and then 2 and it goes up by plus 2 plus 2 plus 2 as it goes on.
Yeah, yeah, yeah. Now, I got it. There is a relation. CnH2n plus 2. Why? See, carbon is 1. So if carbon is 1, so hydrogen become 2 and 2 plus 2, 4. If carbon is 2, so 2, 2, 2 ja 4, 4 plus 2, 6. If carbon is 3, 3 2 ja 6, 6 plus 2, 8. Okay. So whenever you want to that anything, methane, ethene, propane, butane, pentane, just put it in the formula and you will automatically get the that compound. Okay. So it is known as the covalent bonding. Covalent bonding means they are
Pairing.
attaching. Oh my
Two
God, your
nonmetals.
line.
Oh yeah.
It seems like
So
some
there's like
co. Okay, okay. I thought some ghost were living with you. Okay, okay.
covalent bonding. I think it's two nonmetals that are sharing electrons.
In the ionic.
Huh?
Okay, okay. You were saying okay in the covalent. Yeah, yeah.
Yeah, yeah, yeah.
Okay.
In ionic,
Covalent
in
in
I
the
think
ionic, the one is the metal and other is the non-metal.
yeah, they just give it away.
Yes, because one electron is completely getting loose and other electron is completely gaining that. But here they are just mutually sharing that. Okay. Okay. Now let's come to the alkene. If I talk about the alkene, so remember one single bond at least. Not everywhere. Only like if you have so many carbon compound, but in that carbon compound only one double bond is required. Okay, not every location, remember. So suppose if I say methane, but methane is not possible. Why? Because in the methane only one carbon is there, and hydrogen it is saying that you do you want two electron. Hydrogen again, no, I want only one. Carbon is requesting please take two electron. Hydrogen says no, I don't have the capacity. So it means methane is not possible. Why? Because we need two carbon and two carbon, it will become ethene. So that's why methane is not possible. Now we are coming to the ethene. Ethene is very common. I guess you have heard about that. Polythene. If ethene is getting so many times repeated, it become polythene. Polythene bags. Okay, polyethene, polythene bags. Okay. So carbon is there and make double bond between them. Only single double bond. So now how many hydrogen are left then? Two, two. Because 2 is already there. Yes. Because carbon make only 4 bond now, the 2 is already there inside. So 1, 2, 3, 4. So what would be the formula? C2H4 only. Okay. So this is your ethene. If I talk about propene, meth, eth, propene, One, two, and three. So you have to put at least one double bond. So when you put a one double bond here, okay, and rest
Wait,
of the,
it
yeah,
doesn't
yeah,
follow the formula. I think it doesn't follow the formula.
yeah. This one will not follow the same formula
Okay.
because that formula was basically for the alkane. We have discussed this alkane means only single bonds, and here we have coming to the we have come to the alkene portion. So that's why. So here four carbon I need. Here three is already done, so I need only one, and two is already completed, so I need two. So it's become C3H6, right? So now you have to make for me butene.
Is it C4H8?
Very good. If I talk about the butene, so double bond should be at the one position and rest of the portion. So we will get C4, 1, 2, 3, 4, 5, 6, 7, 8. So where what is that? So it means hydrogen are there na at these positions. Okay, I just didn't draw that. Okay, these are the hydrogen. And the last, of course, do you know the shampoo? Very famous shampoo, Pantene. Okay, it is available in the markets. Pantene. So Pantene is the same. So what would be the formula for the Pantene?
Oh, C5H10.
Yes, C5H10. So it is again becoming the symmetry, right? 2 double of 4, 3 double 6, 4 8. So what would be the formula? Cn for the alkene,
Two
CnH2n
Yeah.
only. So this is the formula for the alkene. Now, if I talk about last one, which is called the alkyne. So if I say it here, alkyne means one triple bond is there. Okay. So, methane is possible? No, because we need two carbon. Okay, ethine is possible? Are you sure ethine? Is it? Uh, are you sure about that, Vishnu? Ethine is not possible? Okay. Okay. Suppose if you have the two carbon, so carbon has the valency of 4. So carbon can make triple bond, na? Carbon has the ability. So only one hydrogen is left, and here only one hydrogen is left. So what would be the formula? So the formula would be C2H2.
Wait, H2 or
So
C2H?
yes. So it is
C2.
C2H2, yes.
How is it two? If there's triple bond.
Carbon number 1 and
Oh,
carbon number 2. Okay. And methane is not possible because for the single one. Okay. Now meth it propine. Prop
oh, is
means
it
three carbon and I
C?
means triple bond. Only remember, only one side triple bond you have to put,
Okay,
not everywhere.
is the formula CnHn?
Just one second, just one second. Yes, so what I was saying, so I was saying about the propine. So propine meth it prop. So three carbon were there, right? So triple bond. And so if a triple bond is already there, so only one carbon is coming. So in the this middle carbon, four is completed or one hydrogen is required. Are you sure? Check.
Oh wait, they're done. The four is
Yes,
good. Four is
yes,
good.
1, 2, 3, 4. Okay, it is done. And now this carbon has only one, so it requires three more. Okay, so it means We can say C3H4, right? Okay, now you have to make a structure for me, butane. Butane. What is the formula of the butane?
C4H6.
C4. You just guessed or you just draw?
I drew. I mean, I kind of guessed, but it's like the
Okay.
pattern thing.
Okay, got it. So we have the four carbon. Okay,
Oh,
and
can I draw it actually? I think I can do it.
okay. So rest of the portion just attach with a single bond. So if this carbon is attached with triple bond, so only one hydrogen. Okay, do I put one hydrogen here at the carbon number two at this
No,
side?
it's filled. It's good. It's good.
No,
It doesn't need it. It doesn't need it.
yes, it's done.
You need
This,
two on the. You need two on the that one right there.
yes. So it means we can say C4, 1, 2, 3, 4, 5, 6. So it becomes this 6, right? So now, after seeing these formula, can you make a general formula for alkyne?
I think so.
So try. If it
Okay.
is CN, so now what should I do? H should be what? Is there any kind of relation?
It's n minus one times two.
N minus 1 times 2?
Yeah, it works. It's Cn minus
Okay,
one.
okay, okay. So,
Okay.
okay, can we say, can you are completely right, but can
Okay.
we also say 2n minus 2?
Yeah.
Okay, very good. So n minus 1 into 2, so just multiply the 2, it become 2n minus 2. Okay, so we can say 2n minus 2. Okay, so double and then subtract 2. So this is the formula of the alkyne. Very simple, I guess. So we have completed the portion of the alkene, and the alkyne. Okay. So alkene, remember, remember, these single bond, which is the alkane, we call it as a saturated. Okay. And these we will call it as unsaturated. We will discuss later. Double bond and triple bond are called the unsaturated. Okay. So remember unsaturated carbon and the unsaturated carbon. So you should remember that. After that, we have the certain functional group. Functional group means like these structure not about the bonding, but they are basically about the structure. Like if something is going to be, if some structure are going to be attack on this carbon, like some structure is attached. Suppose if I say I have a butane. Okay, butane I have. But on this butane, some structure is attaching here. Fix the structure. So that can be functional group. Okay. So we have, as of now, you should remember because we will discuss about the biomolecules now. So you need to understand basically three. First is the OH group. So OH is known as the alcohol. Alcohol, I guess you know it. Yes. Yes, is control. Okay, so if I talk about the alcohol, which means OH, so and its suffix is all. Its suffix is all. Okay, and OH we have to put. If we have another one also, CHO, it is called the aldehyde. And aldehyde name is last suffix is al. Okay, like null mostly. If I talk about the CO, this is known as the ketone, and for the ketone we have to put on. On means
Acetone.
one on, like methanol, propanol, butanol, non on. Okay, and last is the COOH, which is called the carboxylic acid.
Yeah, I remember that.
I guess I told you this.
I remember you
I guess.
saying that in like
Okay.
way back when.
So COH, and we will call it as oic acid. Oic acid. Okay. So we have basically the all, al, non, oic acid. So in of course we can make anything like all means like methanol, butanol, ethanol, pentanol. Now ethanol, methanol, pentanol, butanol. Now ketone, methanol, ethanol, propanol, butanol. Now methanoic acid, propanoic acid, pentanoic acid. Okay, so these are the structure which we have to attach on the structure. So let's first discuss about the alcohols. So if I talk about the first methanol, so first write the methane and then put all, so it becomes the methanol. Okay, and there is a soap also, synthol. Okay, I guess available in the market. Okay,
I've heard
synthol.
that. I've heard of it before.
Yes, all. Okay, so it's a kind of alcohol because alcohol is helpful in killing the germs, na? Like
It's a
people are
disinfectant.
using the alcoholic sanitizers.
Disinfectant,
Okay,
yeah.
yeah, so that's why, and nowadays very common. Okay, coronavirus. Oh, I just heard in the US, it's around like 2 lakh cases per day yesterday. Is it true that?
Oh wait, 2 lakhs is 100,000 or 200,000, right?
Oh my God, 2
Yeah,
lakh per day.
I don't know if that's true.
Okay. I don't know, but in India, there was a WhatsApp message. Like in US, it's around 2 lakh per day cases. So it's an explosion of corona in US. It's like that. And I know, then I search on the Google and then I saw around 1 lakh something cases per day yesterday. I don't know. I just saw that. Maybe. I guess 1 lakh is yes, it is high, yes, but still.
Oh wait, no. I think it's I think it meant 2 lakh deaths overall.
Okay, 2 lakh that overall.
Yeah, since the outbreak.
Oh, 1 second.
I mean, you have to also account for tests. Sorry if I'm being loud. My family.
No, 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 it's completely fine.
Oh shit. Uh,
I don't know, we get the messages like that. It is saying that oh, you can't read that. Okay. In past 24 hours, USA reported 2 lakh cases of COVID-19. Yes, 200K cases per day. It is saying the news. Maybe fake news. It might be. Okay. Now we are coming to the portion. Okay. So methanol. So are you safe? I mean, I just heard many people have already got infected and they have recovered. Okay, good. So I guess mask is compulsory, right? Whenever you are going outside. Okay, okay, okay. And schools are closed. Okay,
they're
but
all online until next semester.
okay. So online classes are going on.
Yes.
Okay, okay, okay. So now if I talk about the methanol, so methanol means only one carbon is there, and all means OH we have to put. So one OH is coming. So rest of the position. So rest of the position, of course, we have to put hydrogen because it is all about the hydrocarbon, na? So what is the form? Now remember, this hydrogen and this hydrogen you can't combine. You have to write it separately. Okay, that's why it is an indication. So it
It's
become the
it's it's
CH3OH.
yeah. See, it's
So this is the formula of the methanol, CH3OH. Now if I talk about the ethanol, so ethanol means two carbon, right? So if you have two carbon and at one location only, you don't need to put to two OH, only one OH is sufficient. So write it here, I mean attach this OH to this carbon, and at the rest of the position you have to attach the hydrogens like that.
C2H5 eight. Yeah, C2H5OH.
Yes, completely right. C2H5OH. Okay. And now if I use methanol, ethanol, and then propanol, so propanol we need at least three carbon, And in this 3 carbon, of
Oh,
course,
it's
you can attach OH this side, and we are going to get how many hydrogen bond? One, two, three,
seven.
four, five, six. So it would become C3H7OH. Am I right?
87OH. Yeah, I said that.
Okay, cool. Now, and the last is you have to draw the butanol. Okay, it's time to sleep. Okay, what's the time right now in US?
10:40 p.m. I'm not
Oh,
sleepy. It's just I don't want to draw
okay,
this.
okay, cool. Okay, so now butanol. So you have to tell me the formula for the same butanol.
Oh yeah. C4H9OH.
Hmm, nice guessing. Good, good.
Is that
Okay,
wrong?
so you were guessing right or you were drawing?
No, I didn't draw that.
Okay. Remember, because some in the examination they will ask you the like drawing structure also. Okay. So butanol, of course, we have to put it here. Okay. And rest of the position, of course, the hydrogen. So it become very well said. C4H9OH. So this is how the alcoholic group nomenclature. Okay, we have to do it. So I guess it's quite clear to you. Now we are going to discuss about the aldehyde here. So aldehyde means CHO, and CHO means its a structure is something like C double bond OH. Okay, and that carbon is inclusive. It means in the naming you have to include this carbon, not exclude. The functional group carbon is including. So it means if I
Can you
say,
elaborate on that? I don't really understand
yeah,
what.
I'm going to tell. If you have a methanol, so if you have to use only one carbon, so one carbon means so you have to use only that group only, C double bond OH, and here one hydrogen would be there. So this is the functional group na. Many people say what, sir, meth means one carbon, and al means this group, so they will make something like this. No, that become the ethanol, because we have to include that carbon, so it is not the methanol. So methanol is this, only one carbon you have to see. Okay, so we can say
So in order for the initial carbon to be satisfied, we have to add another H to the.
yes,
Okay.
so we have to
To
use the
complete the octet
SCHO.
rule. To
Yes,
complete.
we have
Okay.
to maintain the octet rule. Yes, four carbon for, I mean four hydrogen for the carbon.
Can you
Meth
give me?
now,
Can you give me a second to like note this down?
yeah, sure. And if I talk about the ethanol, so ethanol means there are two carbon. Okay, so in the two carbon, one side you have to attach the CHO, but you don't have to put extra CHO. You have to include that carbon, right? I told you. So include this carbon. So C double bond OH. You don't need to put extra CHO. You can make it CHO, okay? And the rest of the portion, of course, the HHH. So it become what? And I told you CHO should be written separately, not combined. You don't need to combine the hydrogen to these hydrogens. So we can say CH3 and the CHO. Okay. Like there are dogs. Okay. There are some street dogs. There are some pet dogs, right? So pet dogs can live with these street dogs? No, na. So that's why it is our home pet H, and these are the street dogs HH. So you don't need to combine them. Methanol, ethanol, and then propanol you have to make.
Okay, so
What?
you don't combine the aldehyde portion to the eth what's it called?
Yeah, sure.
Alkane portion.
Yes, try to give me the formula structure for the propanol.
Okay, just give me 1 second.
Sure,
I'll
sure.
yeah.
Take your time.
Oh wait,
Mhm.
is it just okay?
Can you use the pen or pencil to draw it? Because yes, you can guess it very good, but if you draw it, then it would be more fine.
Yeah, I'll draw it. I'm having a hard time guessing this one, so
Okay.
I got it, sir.
Hmm. Propanol. Hmm.
C2H5CHO.
Okay, quite good. So we can say it is C double bond OH. Okay, this is the aldehyde recognition, right? You have to use that separately. And rest of the thing, of course, everywhere you can put the hydrogen to make the valency 4. So it would become C2H5, very good, and CHO. Okay. By looking at this, of course, we can easily identify it as aldehyde. CHO, CHO. Okay, quite good. So it means we have completed the alcohol and the aldehyde. Okay. And remember, we will also discuss the ketones. So in the biomolecules like carbohydrate, protein, fats, we have to use the alcohol and the aldehyde. Okay. Like if I have carbohydrate, carbohydrate means like glucose, fructose, okay, sucrose. So they have the alcoholic group and they also have the aldehyde group. Okay. That's an alcoholic group. Like when the alcoholic group are present on the carbon, so it is also called as hydroxy. Like when other functional group are also present na, then we will call it as OH as hydroxy. So that's why, and there are so many hydroxy, so you will call it as polyhydroxyaldehyde and polyhydroxy ketone. So carbohydrate, there is a definition, proper standard definition for carbohydrate. So in the carbohydrate, there are so many OH and only one aldehyde or ketone can be there. So that's why we call it as polyhydroxy. Okay, very good. So polyhydroxy ketone and the polyhydroxyaldehyde, we have to remember for the carbohydrates. Okay. Actually, when I was in school, so my teacher said, okay, tomorrow I will ask the definition of biomolecule. We will ask the definition of carbohydrate. So we, hey, why is it so much important? Carbohydrate means hydrates of carbon. So we never, like, we didn't even Google, and we even at that time we don't use much Google. Okay, so we didn't study that because we know that hydrates of carbon. So teacher asked in the next class, yes, I told you I will ask this question. So yes, what is the hydrates of carbon? Yes, you, Mr. Savuswamy. Okay, yes sir. So of course it's the hydrates of carbon. Okay, so you studied this at home. Well, I'm carbohydrate means hydrate of carbon. मैंने कहा yes sir. Anything else? मैंने कहा no sir. Okay, and can you give me example? Yes sir. Glucose. Anything else? No sir. Okay, now shut down. Okay, okay. Then he said the standard definition for the carbohydrate is polyhydroxy ketone and polyhydroxyaldehyde. And we were like, what? Polyhydroxy, what is that polyhydroxy? So then after some time we realized, oh, he was expecting some standard definition, not the like sixth, seventh, eighth class definition. And I just said this seventh, eighth definition, so that's why he was quite disappointed. Okay, so that's why I remembered that very carefully. Polyhydroxy ketone, polyhydroxy means so many OH group, and it can be ketone or it can be aldehyde. So aldehyde ketone is optional, any one can present, but hydroxy should be so many. Okay, like I can draw the, I can, do you know the glucose structure?
Yes,
Glucose.
I think I do.
Yes, C6H12O6. Okay, so but if I draw the close structure of that,
Yeah.
okay, so close, I'm going to show you like how it look like. Just give
Wait,
me
how do
one
you
second.
draw that? Okay.
Glucose. Yeah, I can draw that. Just give me one second. Yes, I guess you can see that. Yes, can you just see there at the right side? Okay, so it's a like carbon 6, and you can see OH, 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 OH. So that side is polyhydroxy, hydroxy OH, and this O actually it was actually CHO, but because of the bonding shifting, so you are only able to see the O here. Okay, actually there is a shifting of the CHO, making the bond with the, I will tell you how. Okay, it is better to show you this structure, not the close structure. This is also glucose. Now can you see that CHO? CHO, it is aldehyde, and OH. Okay, polyhydroxy. So now definition is clear. Polyhydroxy aldehyde or polyhydroxy ketone. Polyhydroxy ketone is usually take place in the fructose, and polyhydroxy aldehyde is take place in the glucose. Okay,
Can you say that last part again?
yeah, polyhydroxy is the same. Aldehyde is present in the glucose, and ketone means CO, it is present in the fructose. Okay, that the thing will, I will explain the next class also. Okay, so I hope it is clear to you. Polyhydroxyaldehyde for ketone, polyhydroxyaldehyde is for glucose, and polyhydroxyketone is basically for the fructose, and all these are the monomers of carbohydrate: glucose, fructose, galactose. Okay, so today we have studied the biomolecule, and in the next class we will discuss about the ketone and the carboxylic acid. Okay, enjoy. Bye bye. Take care.
Have a good one. Thank you.